That's not the right one. That's the right one. Hello, and welcome to, I think we're at 115 of the Melbourne AWS user group, and the third in a row that we're back in person, which is a fantastic achievement. And I forgot to bring up my notes before I started the broadcast, but hey, one day we will get it perfect. So welcome. Let's get straight into this so we don't waste everybody's time too much on my introductions. I'm on the wrong side again, so be this side. So, in the spirit of reconciliation, the Melbourne AWS user group acknowledges the traditional custodians of country throughout Australia and their connections to land, sea and community. We pay our respects to their elders past and present and extend that respect to all Aboriginal and Torres Strait Islander peoples today. Let's kick off straight away. I should really switch sides on this, shouldn't I, so I don't have to stand over here. That's all right. So we've switched the format up a little bit back to what we were doing during the pandemic when we were fully virtual, just to make it a bit easier for people watching on the live stream. Hello, if you're watching on the live stream, so that you don't have to have a break between 7 and 7:30. We just run straight through now. It makes it a little bit easier to participate. So that schedule is more or less the same. If you've been to one of our events before or you've watched online, it should be pretty familiar. This is the introductions that I'm doing now. We'll have Ian and Dawn will come up and talk to us about what's new in AWS since the last time we got together. And then we have our two speakers for this evening. Phoebe is talking to us about saving the Tasmanian devil using Amazon recognition, which I'm sure is going to be really, really fascinating. We will have a quick 5-minute bathroom break for our marketplace segment after that as well. If you are looking to hire people or if you're looking for work, this is your chance to find each other in the room or online and make that connection. There'll only be a 5-minute break though. We'll be straight back then with Matt, who is taking us through everyone's favorite Kubernetes topic, but he's going to be arguing the other one as opposed to the fanboys who are quite often around Kubernetes. Matt will be telling us why it's not the answer. And then we hopefully wrap up, around 5 o'clock or so, around 8 o'clock or so. That'd be a bit early. So we encourage you to ask questions, both here in the room or if you're watching on the live stream. If you are watching on the live stream, please ask any questions either in our Slack channel, where the details will be up in a moment, or you can ask on Twitter or there on YouTube. I'll keep an eye on those during the presentations, and then if you do have any questions to ask, I will ask the presenter on your behalf. Or it might be Ian. We'll see. We'll mix it up a bit as we go. And then at the end, so please hold any questions if you're in the room until the end of the presentation, just so we don't interrupt the speaker. And at the end, you'll have an opportunity to ask the presenter any questions. Again, I'll do that for the live stream audience. We also welcome any feedback. Either come and grab myself if you're here in the room, or Ian, or Dawn, or Matt, who's down the back hiding. Always welcome feedback, especially with the change in format. We need to, if you don't tell us if something's going wrong, then obviously we can't fix it. And again, via those same channels if you're watching online. All right, so sponsors. We can't put these events on without the help of our sponsors. I mean, the obvious benefit of that is the drinks and the food down the back, but there's quite a lot more that goes on to putting these events, including equipment. We have our own AWS build too, and that sort of stuff, so there's a fair bit that goes on there. So a big thank you to CMD as our gold sponsor. That's the before times, Chris. And our silver sponsors, Versant and Civo. And I don't have a slide for it, and I really should, but I'd like to also thank NAB for hosting us again from last month, this month, and for the rest of this year in this great space. So thank you to NAB. All right, so a little bit of who are we? My name is Rob. I go by @Bok on Slack, or I'm @Bok with probably an underscore or a dash on most social media, depending on when I joined and what was available. And my co-host is Ian, who you'll meet in the next segment. We don't work for AWS. We're members of this community the same as you. We work with AWS day in, day out, but we're not working for AWS, if that makes sense. So we intend for this community to be a safe place for any views that you might have about AWS, good, bad, or ugly. We welcome all opinions here, even if they're negative about Kubernetes. We're not too fussy about that one. The best way to connect with us and with the community is via Slack. Website is up there. We have several hundred people on there. I think it's 800 and something last time that I looked. And it can be busy during the day. Some days it can be quiet. Other days it's a little bit hit and miss, but it's still a great place to connect with your fellow community members, ask any questions that you might have, and so on. We do have a bunch of side channels like the jobs channel, and there's some outage channels as well. And some announcements channels if you want to discuss what's new. And we're always looking for people to get involved. The hardest part of putting these events on generally is finding people who want to come up and speak. But we accept speakers on all topics, all presentation length. Doesn't have to be well scripted, well rehearsed presentation that you've given 3 times before. Some of the best ones that we have are off the cuff. You've found a cool tool that helps with managing AWS credentials, and then you come up and tell us about it, and that's how we all find cool tools. So it's really helpful that way. We will be looking for sponsors again for the rest of the year, I think. Watch this space if you're interested in sponsoring the group. We'll figure out when that looks like and what that looks like. And we're always looking for volunteers as well. The obvious being helping with the room setup and clean up and that sort of stuff, but there are other activities as well that we'd love to do, like video editing and things like that we just don't have the resources to do. All right, so that's all of that bit. reInvent is on again this year, and I believe that ticket sales have opened. That's what you told me, yeah? So ticket sales are open if you want to go attend in person this year. I think it's around the 1,700 mark, something like that, US 1,800 mark. Is anybody thinking of going? Nobody's planning a trip to Vegas this year? Maybe one person? It's understandable. I imagine they're still going to do the full suite of virtual things and not require you to be there, but if you do wish to go, the option is open to us again now. So details either way are on the reInvent website. A little bit closer to home, the Programming and Tools user group has an event on 2 weeks from now where they're going to help run through the AWS CDK. That's an online event where you bring your laptop and you can participate in it's effectively like a classroom style learning online. If you've never played with the CDK, this is a great opportunity to get an introduction, a hands-on introduction to how it works. And with that, I will get out of the way and we'll bring on what's new. And plug back in.
Wouldn't you like to know? Sorry, the laptop is a bit...
Technical difficulties, please stand by.
Never close your laptop when it's in presentation mode. Why is it being difficult?
I feel like we need someone to... Is this actually connected?
Well,
Okay.
I took it out because seeing if that needed. One moment, please.
You good to go?
Good to go.
Fewer technical difficulties?
Cool.
Nope. Yay, there you go.
Hold on. Yeah, whatever. Cool. What's new? A working laptop. So, as Rob said, welcome everybody. It's good to see so many faces in person. Still getting used to it. I was at the summit last week. There were even more people there, and it was a bit scary almost. But let's talk about what's new in AWS since last month. For those of you new, the first slide is always reserved for finally in Sydney. Services that were not in Sydney before, they already existed, but we did not have access to them. But now we do. And there's a couple of them this time. So first of all, the new RDS multi-AZ option is available. In case you missed the announcement for that, I think it was last month.
Yeah.
In case you missed that, it is the ability, instead of having an RDS that doesn't do anything, but is only there for failover, you can have 2 extra RDS instances that run as read-only options.
I expect that AWS are going to have to rewrite a lot of their exams. This may be somewhat connected to the announcement that the Solutions Architect professional exam is changing. It is going to drastically change the way that pretty much everyone running on AWS with any sort of redundancy in their RDS architects their systems. It's a huge improvement.
Yep, it sure is. The other ones are several new instance types. I can't recall at the moment what the R5B instances are. Did you?
Not off the top of my head. The smorgasbord of letters and numbers is getting so complex that it's extremely difficult to keep track of them.
Yep, it certainly is. And that's exemplified especially by the last ones, which are the X2IDN and X2IEDN. These are 2 instance types specialized in extra memory as well as extra network bandwidth, and the E stands for extra. So that one has extra memory. In case you need it. It's basically designed for SAP applications because nothing else needs that kind of memory.
Yeah, it's a very niche use case, and the general expectation would be that very few people will use these.
Yep. So let's move on to more general things. Serverless. Thank you, Chris. Lambda supports Node.js 16. This is good if you're using Node. I don't. I try to avoid it. But don't hate me for that. But yeah, it's great. New versions, always good.
Yeah. The managed I can't remember what the exact terminology for this one actually is, but this is the AWS managed Kafka service. Is the serverless version of that is now general availability. I don't know how many people actually use AWS managed Kafka servers, but theoretically being able to do this in a serverless manner should save you some money.
Yep. Just keep in mind that it's serverless in some air quotes because it's not serverless like Lambda, as in you still have things running.
As I said, theoretically will save you some money. Your mileage may vary, and do make sure that you work out the pricing before you actually switch over.
Yep. The other two announcements here are more quality of life improvements. The SAM CLI supports being able to turn on X-ray, which is great, and Step Functions has a new console that is especially good for debugging. I could tell you about it, but I recommend just reading the blog post because that actually shows things, and it's hard to paint a word picture around how well this works.
Yeah, definitely glad to see Step Functions getting a little bit more love.
On the container side, everybody's favorite servers, except for Matt in the back there, EKS. The EKS console lets you see all standard Kubernetes resources. So in the past, it would hide some of the basic stuff for you. Now it just shows everything.
For people who use Kubernetes, this is definitely a good thing. It's something that is a personal bugbear of mine when cloud services abstract away things that they really shouldn't, particularly for people who are just getting started with this sort of service. It makes it much more difficult to follow what's actually going on. So I'm all for this one.
Yep. Kubeflow on AWS. This is a project from AWS to... Did you remember what this one was?
We're not
Sorry.
We're not doing very well this month, are we? Yeah.
Yeah, that was... Thank you. Yes, it's a machine learning tool to run your machine learning things more easily on Kubernetes, and this is specialized. This is focused really for running it on EKS or just in the AWS cloud.
Yeah. Probably in the vast majority of cases, if you are running a machine learning workload, there are almost certainly better ways to do it than on Kubernetes. So unless you're Google, probably not a tool that I would recommend that anyone try.
AppMesh supports IPv6 as Kubernetes and VPCs and all that got better IPv6 support in the past. It's good that the AppMesh, which is the service mesh service from AWS, now actually supports being able to call those endpoints. It's kind of a hard thing otherwise to use this in combination.
Yeah, it remains to be seen whether the improved IPv6 support in AWS is going to result in more of the internet moving towards it, but considering how long it's been a standard, I'm not holding my breath.
Yep. On the DevOps side then, we've got CDK support for Service Catalog. This is actually in two ways. You can call Service Catalog, you can use Service Catalog products, items within your CDK applications, and you can write your Service Catalog items in CDK instead of just pure CloudFormation.
I really like this. This is a very, very good quality of life improvement, particularly if you have organizations where most people working there are developers and don't necessarily have notable ops experience. Being able to roll everything into CDK is really important for them. So seeing more and more of the opsy AWS services get CDK support, I think is overall very, very positive for the ecosystem.
Yep. CodeGuru Reviewer allows suppression of files, folders. If you use CodeGuru Reviewer, I suspect not many people here, you can now tell it to not look at certain files and folders. This can be useful if you have some legacy code that you're never going to clean up or things like that.
Yeah, that's about it. There's not really much else to say about that one.
Did you want to talk about any of the others? Or?
Yeah, the incident manager expanding the runbook automation is sort of interesting in a very niche way to me, because this is a service that I have looked at a few times, and there's just it's one of those services where you feel like it could be so much more than it is. So I'm glad to see that there's a little bit going into that now, and I'm really hoping that there's more automation that goes into that service in the near future.
Cool. Then on the security side, one of my favorite announcements in a long time is the SSO delegated admin.
Yeah, this is this slide's probably more my wheelhouse than most of what we've had before. SSO delegated admin is an absolutely amazing. This is fantastic. What it essentially allows you to do is, rather than having to manage your AWS SSO configuration from your org management account, you can now delegate the management of the SSO into a separate account. If you are dealing with a really big enterprise where, say, you have one team managing the AWS platform, but you're doing identity using something like Azure AD or Okta, this now allows you to delegate an account to the team that essentially your team that's doing identity management, so they can manage all of the SSO themselves. I expect this to be adopted very, very quickly in a lot of big orgs where that sort of communication between those two teams has been a massive bottleneck to things actually happening. I've been in that situation once myself. I wish we could have just delegated it. So this is a really, really good announcement.
Yep. I definitely wish it had been around for a longer time. As this is so much in your wheelhouse, anything else here you want to?
Yeah, Secrets Manager with the usage metrics is one that I think is interesting. I think that's another one where I think your primary use case is going to be in really big orgs that want to understand how they're actually utilizing Secrets Manager and potentially pick up some of those patterns that they might get where information is in there, but people are sort of exfiltrating it and they're doing things in ways that they shouldn't be. So that's really positive for getting everyone around and being able to actually audit, are people doing things in the way that they should be? And Control Tower, my old nemesis at the bottom there, I'm very, very glad to see that as slow as it has been, the promised evolution of Control Tower is actually happening. The customer-provided core accounts in particular, if you're trying to migrate from an AWS landing zone, this makes it orders of magnitude easier to do because you can just take the accounts that landing zone generated for you and plug them straight into Control Tower. So it's reaching the point where it's a usable service.
Yep. The other thing of note with the Control Tower is the Python 3.9. Basically, last month, Python 3.7 went end of life for Lambda. But all of Control Tower, all the Lambda functions it creates were Python 3.7. So a couple weeks later, they upgraded all of those to 3.9. So you'd stop getting messages from AWS that you should update your Lambdas.
Yeah, it would be nice if next time they updated the Lambdas before they end of life them, but we'll see how that goes.
Yep. And then our last slide. New instances. So the big one here is probably the C7G. These are the Graviton 3 instances that AWS pre-announced at reInvent. They are, I think, 25% faster, use like half the power from the C6G instances, even bigger differences with the Intel machines or AMD. A nice side effect of this as well is that AWS once again made the T4G instance, T4G micro instance part of the free tier. So you can play with ARM-based instances for free just to see how it goes.
Yeah, definitely seeing the AWS Graviton instances get first-class support now, which is overall, I think, going to be very beneficial in most use cases.
And And the other one that I want to call out here, because it's pretty cool, is the RDS for Postgres cascading read replicas. This basically means, so you can, in general, you have 5 replicas. Okay. You have 5 read replicas for your instance. Now each of those 5 read replicas can have 5 read replicas, and those can have 5 read replicas as well. So that gives you a total of 155 read replicas. If you have a workload like that, please talk to me. I would love to see that.
Yeah, I'm absolutely in agreement with that one. It's funny how the same things caught our eyes. This is I really want to see what workload is so read heavy that you would need 155 dedicated read replicas. I also really want to know how much architecting time went into this, because this must have been a hell of a feat to pull off. But there has to have been some customer request somewhere, hey, this is what we're looking for this to actually come out. So kudos to them, I guess.
Yep. And I think with that, that was all the news. So thank you, Don.
Thank you, Ian.
And on to the speakers.
Thank you, Ian. Thank you, Dawn. Get you plugged in. Just wait for that to pop up. There we go. I can see your desktop. Perfect. All right. Just before you get started, you need that one. Okay, so our first speaker tonight is Phoebe. Phoebe is a senior data consultant and has been working at, is that Altus?
Yes.
At Altus for 2.5 years. That's a pretty good run at a single tech company. While studying mathematics and computer science at La Trobe University, she discovered a love for data. At Altus, she is working with clients across the data pipeline to help them with their data solutions. Phoebe believes in data equity and has been volunteering her free time with Data for Good, a not-for-profit that aims to make data solutions universally accessible for businesses focused on solving community and global issues. This is also Phoebe's first presentation at a user group, so please give her a warm welcome.
Thanks, everyone. So hi, I'm Phoebe. Thank you.
Just hold it up a bit closer.
Okay, cool. Hey. So yep, thank you everyone for coming and watching. Today I'll be taking you through the Data for Good Tasmanian Devil project, which used Amazon recognition. Since the devil facial tumour disease emerged, 80% of the Tasmanian devil population has been wiped out. Luckily, there are people like the Tasmanian Nature Company who are trying to save the devils. In my free time, I've been volunteering with Data for Good, who are working with the Tasmanian Nature Company. First, acknowledge that I'm on the lands of the Wurundjeri people, who have been custodians of this land for thousands of years, and acknowledge and pay my respects to their elders past and present. So this is a little bit about me. I've been working at Altus. It's almost 3 years now. We're a data analytics company working with AWS, Azure, everything, and also doing a bit of everything with data. So AI, ML, data visualizations, data engineering, all of that. So if you have any problems or want to join, come have a chat to me. We're always looking for people. So today I'll begin by taking you through the background of the project, explain the problem that we've been working on solving, and then I'll go into detail about our current solution and the next steps for the project. So what is the Tasmanian Nature Company? It's a specialist nature tour operation that runs conservation tours on the Tasman Peninsula. They also have a groundbreaking wildlife centre, the UNZOO. I don't know about you, but whenever I go to a zoo, I always feel a little bit sad for the animals stuck there. So the UnZoo aims to address this issue. It's a reversal of a traditional zoo, so there are no enclosures. Instead, it invites visitors into animals' natural habitats, and their cages and barriers have been removed or concealed, and wild animals are encouraged to interact with the environment. This gives animals more dignity, freedom, and self-determination, and humans get more personal and memorable encounters. In 2007, John Coe, a legendary zoo designer, came up with an UnZoo master plan for the Hamilton family farm. The bush surrounding the UnZoo attracts a whole lot of native animals. So some animals that reside there include possums, wallabies, echidnas, bandicoots, wombats, spotted quolls, echidnas, and almost 100 species of birds. But most importantly, it also has the last wild, disease-free devil population. So before dingoes were introduced to Australia around 8,000 years ago, Tasmanian devils were actually found across the whole of Australia. Unfortunately, dingoes wiped them out. But because Tasmania had already been separated from the mainland, the devil population continued to thrive there. Tasmania is the only place in the world where Tassie devils exist. So the UnZoo is located in the Tasman Peninsula. So here's the Tasman Peninsula. This area is perfect for the UnZoo as it's almost an island. You can see the canal here that separates it from the rest of Tasmania. So this canal has been enhanced by the UnZoo to protect their wild devil population. This is the Google Street View of the bridge over that canal. It's unlikely that any Tassie devils would actually cross this bridge, but there are also barriers placed in the water to stop any devils trying to swim across, which also is very unlikely, but just to protect them. So why all this effort to keep the devils separated from the rest of Tasmania? The devil facial tumour disease emerged in 1996, and there's no cure. Tumours form in and around the mouth, which affects devils' ability to hunt and eat, leading to starvation. It's spread through normal behaviours like playing and fighting. In diseased areas, nearly all sexually mature Tasmanian devils, those older than 2 years of age, become infected and succumb to the disease. Juveniles as young as 1 year old can also be infected. This is resulting in populations with a very young age structure, in which females only have one breeding event, whereas they would normally have 3. If the disease gets into the UnZoo, it will only be a matter of time before Tassie devils are extinct. Due to the isolation of the Tasman Peninsula, the disease has not reached there. It's the last safe haven. So a second type of the facial tumour disease actually emerged in 2014. There are differences, but they're both fatal and kill in months of contracting the disease. It's extremely difficult to get data on the general population of devils due to their decline. There's no evidence of the disease stopping, but there's evidence of the devil population disappearing. On this map, there are only 2 green dots for data collected in 2018. Prior to 2018, there were cases of facial tumour disease in the UnZoo, but the Tasmanian Nature Company cleared them out and it's been disease-free ever since. So to keep devils safe, the Tasmanian Nature Company set up the Devil Tracker project, which monitors wild devils on a daily basis using infrared night cameras around the UnZoo. The camera takes a photo when it detects movement, such as an animal walking past at night. Various animals appear in these photos, as it's just whatever happens to walk by. To make sure they get photos with animals in them, they have 3 food traps set up, so just a bit of food on the ground. Each day, an employee has to go out to these traps, replace the food, and collect the SD cards, then manually go through every single photo that was taken overnight. If there were any photos of devils, they have to save them and check those photos for facial tumour disease. This is extremely time-consuming and difficult work, and I know I'd get bored of it really quickly. They currently have over 60,000 images, but they're just sitting on a hard drive in the UnZoo office. Let's just take a step back and imagine what kind of insights and information these photos hold. Information about where individual devils go, how often they go back to the same spots, and other general insights into their wild behaviour. Now can you imagine what UNZOO and Tassie Devil researchers could do if they could easily access this data? As the population continues to decline, this information becomes more and more important. There is nowhere else in the world that you can get this sort of data on disease-free devils. Luckily, they've not found any diseased devils since starting this project. If they do find one, they would need to get to work immediately to isolate and protect the rest of the population from the disease. So this is where Data for Good comes in. It's a not-for-profit that encourages data professionals to use their data skills for purpose, not profit. If you're interested in helping out, you can contact me or go to the Data for Good website. There's lots of projects and we're always looking for more projects. It's a great way to learn, meet new people, and try new things. So working with the Tasmanian Nature Company, the Data for Good project team narrowed it down to 3 key questions that our solution should answer. The first is there a Tasmanian devil in the photo? This would just free up a lot of time for the UNZOO employees because they wouldn't have to sit through and manually click through every single photo that was taken. The next question is, are there any signs of facial tumours or injuries? This would turn the photo set part of it into a fully automated process requiring basically no time from employees. And then the third question is, how often are individuals passing through the same spots? This question was one that the Tasmanian Nature Company was interested in finding out the answer to. You can tell Tassie devils apart by their white markings, as each devil has them in different places. With the decline of the population, there's not many places that would have the data available to answer a question like this. If we can train a model to recognise an individual devil, then we'd be able to answer a lot of questions similar to this one. And so we begin our journey. With our first batch of images, we just used Label Image Python, which is a graphical image annotation tool, and we drew visual boxes around the objects in the image. So this is what that looked like. It was just a bounding box, click and drag. This method is great for when you don't have many images. We had around 1,500, but it did help us get a really good feel for the data that we were working with. So we trained and tested a model, like a model that we'd coded. And because all of our photos were pretty much of devils, the model thought everything was a devil. There were a couple of cats in the photo set, I think like 6. The model only knew devils, so it just assumed, yeah, everything was a devil. So here are some example images. You can see where it kept going wrong. One of those is clearly a cat, but if you'd never seen or heard of a Tassie devil, you may just think it was a strange-looking cat, and vice versa for the cat, you may just think the cat's a strange-looking Tassie devil. So we got more photos. We added a non-devil class, but it was still a really uneven amount of photos, so the model still thought everything was a devil. Here's some of those photos. So you can see the small bandicoot. There you can see its eyes glowing. A brush-tailed possum. Some echidnas. A feral cat. Some ravens. Some patermelons. Because there are over 100 different species that live in the UNZOO, not all of them are nocturnal. So we had some photos in colour and some in grayscale because they were taken at night. You can see how similar a lot of these animals look, especially at night and when they're only a small part of the image. On top of that, we only had a couple of images of some of the animals. For example, the patermelons, I think we had 2 photos of them in the whole data set. So that's nowhere near enough data to train a model to recognise each individual animal. On top of that, we didn't really need to recognise each individual animal. The Devil Tracker project really only cares about the Tasmanian devils. So we just made the decision to have 2 classes, a devil class and a non-devil class. So we trained and tested the model again, but it was cheating by using the background. So we thought we'd fix the other issues and fixed any potential issues by changing all the photos to grayscale, but it found a new way to cheat the background. So you can see how different the backgrounds look in these 4 images, even though there's only 3 different backgrounds. The lighting and animal placement make it look a little different. So then we had to figure out a way to stop the model from looking at the background of the photos. We discovered a tool called Megadetector. It turns out that a lot of people have the same issue that the Tasmanian Nature Company has. A huge portion of time is being spent reviewing images that they aren't interested in. So Megadetector was built to allow conservation biologists to spend their time on the images that matter. So this is what Megadetector's output is, that bounding box around the animal. It detects the presence of animals, people, and vehicles in camera trap images. It finds them, but it doesn't identify them. You can see the boxes around the animals, but no label on them. So this is basically an automated version of what we did at the very start of the project. It will also detect multiple animals or objects in the one shot too. So we used Megadetector to create a bounding box around a detected animal, and then remove the camera overlays from the top and bottom of the images and got it to add an extra couple of pixels around each animal as a buffer. We cropped the images at the bounding box when the detection confidence was over 90%, and if there were multiple animals in one photo detected at a high confidence, then we extracted multiple images from it. We also decided to resize all of the images to a square. This was to try and reduce the number of variables because we wanted it to be focusing on just the animal, not necessarily the size or shape of the photo. You can see the cropped and resized images still looks like a devil, just a slightly chunkier, misshapen devil. So by this point, we were really sick of having to write code. So we thought, let's use Amazon Recognition. It's a fully managed computer vision service, and it allowed us to quickly train and test models with minimal coding. We uploaded all the images into an S3 bucket, and then got Recognition to label the photos based on which folder they were in. We used the custom label setting. So then we started the model. And it worked. Thank you. So this was the output for the last version of the project. We had a couple of goes before we finally got it to one. There were just really small updates about what number of images we put in. So this was the output. And here's some of the pictures. So the model could detect the presence of Tassie devils in an image with a high confidence rate. This means that empty images and non-devil images could be separated automatically. An automated system could do this for hundreds of thousands of images per day. You can see it can recognize the backs of devils, but it wasn't getting some of the legitimately difficult ones, such as this one. So yeah, that first one, it didn't really know what to do, which I also wouldn't because it's quite difficult to tell what's there. The model made 41 mistakes out of 2006 test images. Those 41 mistakes gave us confidence that it hadn't found anything to cheat using this time. So some key takeaways were: get more photos than you think you need. Recognition is smart, but it's not that smart, and it can only evaluate what you give it. Crop and resize all your images so they're the same size. Just reduce all the variables you can. Yeah, if the model can cheat, it will. So anything you can do to remove bias in your dataset will help your model so much. And do that before you start running the model to save yourself pain later. So we've solved the first question. So for the next question, we have a bit of issue because we have no photos of devils with tumours from these camera traps, which is great for the devil population, but not really great for our model. So we're currently waiting on images from elsewhere in Tasmania, but those images will have different backgrounds. Maybe could be from a different type of camera. There's going to be heaps of variables that we're going to need to work through. Someone recently got in contact with us and has a whole heap of videos from the south of Hobart with some diseased devils in there, and so they're going to help out with the project. So it's really exciting that we can get all this data. So if anyone else wants to help out or knows where we can get some photos of diseased devils, then please get in touch. So here are some links to the things that I spoke about. Yeah, so thank you for listening. If you want to help out with Data for Good or have any data problems, then let me know. And yeah, does anyone have any questions? Thank you.
So does anybody either here in the room or on the live stream have any questions? Yep, hang on a sec. Let me bring you this.
Amazing project, fantastic. What was the timeline for writing the code and getting the model working to an effective efficiency for you?
So because this was a volunteer project, there were a lot of months where we did nothing because we just didn't have time. So we started in, I think it was September 2020, and then the working model was October 21. Yeah, but there was a lot of dead time of waiting on images to be sent from Tasmania and people just not doing anything, not having time.
So this was during lockdown. How were you guys, or was the project communicating?
We started off on Teams and then we moved to Slack. Yep. But yeah, just we had weekly meetings for a while, and then since the images had to be sent up from Tasmania, that was taking time. So we paused them for a while and started back up. Yeah.
Do you guys consider using image segmentation as an approach to avoid the background and stuff?
Yeah, we did try that, but it didn't. We couldn't get far enough with it. Shortly after that, we tried recognition, and yeah, recognition worked pretty well. So we were like, this is easier.
Did you find out how recognition got to that really high accuracy? Was that transfer learning or some approach like that?
I'm not sure actually. I think part of it would have been what we did to the data set, because we did improve that a lot once we started using recognition.
Cool, thank you.
Really cool project. Probably a dummy question on machine learning in general. Like my whole experience is like one project. Is there any techniques or automation or semi-automated way to check for the cheating part of the model? Like, how do you detect if the model is cheating?
Our results were just super weird. That was how we discovered it. We were like, this doesn't look right.
Cool, thanks.
Yeah.
Is there anybody else? No questions from the online audience either. So we'll call it there. Thank you very much.
Thank you.
Thank you. Ian, you want to run this? So we are going to take a 5-minute break or so. Before we do that, though, this is we do our marketplace segment. So I guess show of hands, is there anybody that's hiring at the moment? Okay.
Cool.
Ian, please say where you work, who you're looking for.
Hi, I'm from CMD. You might know them from the sponsor slide. We're a consultancy. Last week, AWS awarded us the title of Best Services Consultancy in Australia and Best Migration Partner as well. So in addition to that, it's a great place to work. Actually, according to the Great Places to Work survey from last year, it's the best place to work. We're looking for people at basically every level, AWS related. If it's not purely AWS related that you're looking for, we have sister brands that do a lot of other things, from AI, ML to app development, mobile development, all those things. So come talk to me.
Cool. Somebody else had their hand up down here. Please stand up.
Yeah, my name's Tom. I'm actually a recruiter, but I work in the cloud and DevOps market. I've only come over here in the last 4 weeks, so I am actually recruiting in this space for a few clients, but keen to just get involved in this network rather than just being one of those recruiters that isn't involved in the network, and keen to learn more about AWS as well. and Azure as well. I don't know if that's a swear word here, but yeah, that's a little bit about me.
Oh, sure. Hey, I'm from Altus. You can see how it's spelled on my laptop there. We're a small consulting firm for data and analytics. We're hiring all levels. Great place to work, 10 years in a row. Can confirm, really enjoying it. Yeah, anything else?
On average, we've got people here for like 7+ years, and no one stays that long at a 10 consulting, so that's a big plus here.
Is there anybody else that's hiring?
If you disagree with the topic of our second talk tonight and you do want to come and work with Kubernetes, I feel obligated to put in the plug for Enabler because we are, I think, the only cloud native computing foundation certified consulting company in Australia. We do other things as well. We do quite a lot of work with AWS, but I couldn't pass up the opportunity to do the pitch of if you disagree with our second speaker tonight.
Is there anybody else? No? All right, we're going to take a 5-minute bathroom break while we get our second speaker set up. Just a reminder, the bathrooms are just outside the door. We won't be long though, so don't go too far.
Okay, so why is Kubernetes not the answer? So I'm here today to talk to you about the bane of my existence, or at least what has been the bane for the last 18 months of my life. The purpose of this talk is to take as unopinionated as possible, but yeah, you'll see that's not necessarily the a view on what the benefits of Kubernetes actually are and whether or not we should be looking to use it within our upcoming environments and what benefits it may or may not provide to us as engineers, consultants, developers in the IT industry. So before I sort of get into the nitty-gritty, a little bit about myself and why I at least think I'm qualified to talk about this sort of stuff. So, you know, as Rob said, my name's Matthew Merrill. I'm an AWS cloud architect or cloud consultant at Civo in Australia. I've been playing with AWS basically since I think the joke there is since it was called S1, but, you know, at least since it came to Australia in, 2012. I have played a little bit of Pokemon with the AWS certifications, and for a matter of, I think it was 2 weeks, had all of them before AWS decided to retire the old big data one and turn it into 2. So thank you very much, training and certification team. I will get back in it and hope to have all 14 of them now by the end of the year, so we'll see how that goes. Also an AWS APN ambassador and a member of the Community Builders Group. So with all of that, I like to think I know what I'm doing and what I'm talking about. So rather than just get straight into the nitty-gritty technical stuff, I thought I'd sort of set a scene a little bit and let's sort of do a little bit of a role play and sort of frame the conversation a little bit better. So congratulations, you've all just been hired as the head of engineering for a company called Phony Music. It's a division of the Phony Group, and they want to launch a music streaming service because there ain't enough of those in the market already. And because they're a startup and, you know, we want to move fast and, you know, get as much of the market as we can, we need to come up with an architecture running on AWS, because AWS has been nice enough to give us a whole bunch of credit to present back to the investors to get the next round of funding by the end of the week. So we need to very quickly stop and think about what it is that we're going to do and how we're going to go about doing it. So luckily enough, because, you know, we already have an application, and for the purposes of this conversation and to try and keep it aimed on other than the wider AWS landscape, let's assume that at the moment our application is a very simple React application that runs in a single container, and all of the music we're going to stream sits on a central file share. Right. Everything else the application needs, authentication, log storage, all of that sort of stuff, we're going to pretend is all sitting in the container, despite the fact that we wouldn't actually do that in the real world. It just makes this talk a little bit easier. So really all we need to do is take our containerized workload and present it out to the world in a load-balanced, highly available, you know, resilient manner. So really what we want is an environment that's scalable. Right? Pretty simple. We want an environment that's going to be easy to manage, easy to patch, easy to update, easy to change as business needs come up, because chances are we're going to need to change what we're doing. What we're going to do today is not what we're going to be doing in 6 months from now. We need something that's going to be flexible for the developers, because we all know that if we don't make the developers' lives easy, we're going to hear about it later. So we want to keep as well out of the way of them as we possibly can. We need to be able to see what's going on. We need a layer of monitoring, logging, observability, you know, all those fun buzzwords. And we need to be able to make that visible to the whole team, right? The developers need to see what's going on. The operations team need to know what's going on. The management might want to see what's going on. Our logging and our monitoring needs to be highly available and highly visible. We need the solution to be cost effective, because we are going to be one of the only startups in existence to actually really worry about the bottom line and not just go to the VCs for more money. And then finally, because we're a very small team, we need to know that we've got support and the ability to pick up the phone and ask somebody for help when the inevitable arises and it all goes up in smoke and something breaks and stops working. So fundamentally, those 6 things are what we're sort of looking for in a platform. We want it to be scalable, we want it to be maintainable, flexible, observable, affordable, and supportable. Right? Lots of a bull. So with that in mind, is Kubernetes the answer? And I'd ask people for their opinion, but from the title of the presentation, you can probably guess where I'm going to land on that. So what is Kubernetes? Does anybody actually want to have a shot to say what Kubernetes actually is without Googling it? Yeah? A container orchestration service. It's probably about as close as you're going to get. Kubernetes is a portable, extensible, open source platform for managing containerized workloads and services that facilitate both declarative configuration and automation. It has a large, rapidly growing ecosystem, and Kubernetes services, support, and tools are widely available. That is taken directly from the Kubernetes website. So, can anybody tell me what Kubernetes actually is? Because I think his answer was actually better than that. The fact of the matter is, to call it a container orchestration service is probably pretty spot on the money, right? We're talking about a way we're talking about a system that is going to run and present our containers out to a consumer. Now, that consumer might be the end user, that consumer might be a load balancer, it might be another part of our network, but it's going to run the containers, it's going to make sure that they're up, they're available, they're doing what they need to do, it might run some health checks, and it's going to make sure that it can restart them and all of those sorts of base level controls that we might want to give us a nice, healthy, resilient environment. But how much of that is actually unique to Kubernetes, and how much of it might we actually be able to get elsewhere? So to do this, we'll run through 2 potential options here. The first is we'll take a look at Kubernetes and see what needs to be done there, and then we'll have a look and see if we can do it a different way. So let's build some Kubernetes on AWS, right? Because how can that be bad? And we're going to do it on EKS because, well, AWS. And you'll see that there are a few AWS nuances in this presentation. I figured talking about the nuances of Kubernetes on, say, the G1 or the A1 might be a little less relevant for this particular crowd. And let's face it, those platforms don't actually matter anyway. So let's start off with our Kubernetes cluster. The first thing we need to do when we want to run Kubernetes is we need to run a Kubernetes cluster. That's going to be our control plane. That's going to tell everything how it's going to work, what it's going to do, and all of those sorts of things. And as you'll find out a little bit later, it's what we're going to talk to and send instructions to. So that's nice and easy. We can deploy EKS clusters using CloudFormation or Terraform or the management console if you're crazy. However, there is a catch with that. Because Kubernetes is its own unique beast, once you do that, you actually then need to go and do some additional configuration. And because Kubernetes is its own unique beast, that can't be done through the management console or CloudFormation or any of those sorts of things. We actually need to go and configure it through the CLI. We can technically do it through the management console. It's a little bit more annoying. And there's a link there if anybody actually wants to go through and do it. Now, there is technically another way that we can make our lives a little bit easier, which I'll touch on when we get to the manageability piece. But the fact of the matter is that is just a tool that is going to be doing these same tasks. So already we're in a position whereby just to deploy our control plane, we're actually already using multiple tools. So let's say, because we're an AWS shop, we're going to use CloudFormation, but you can pretty much just swap in Terraform here if you want. We use CloudFormation for a bunch of our stuff, and then we need to use the CLI for a whole bunch of the other stuff. Or we need to be running things directly from our local machine, and let's say, that never goes wrong. So we're not off to a great start, but that's okay, because let's face it, how often do we actually deploy Kubernetes clusters? Once the control plane's actually up and running, we've got our things all, hunky-dory, we can actually just progress on with the rest of life, and we can forget about all of that sort of pain. So that's fine. So next we can move on to scaling, and we can start worrying about deploying our Kubernetes nodes and, you know, the things that are actually going to run our pods and our daemon sets and actually make these workloads available. Now, again, for the purposes of the conversation today, you know, we can run our Kubernetes nodes on our EC2 instances, and we can do it as a managed node group, and, you know, we can provision all of these things. We can do it ourselves. And when it comes to the configuration of the EC2 instances, we will ignore the whole image building thing and having to bake our own EC2 images or have some kind of configuration input and all of that, because that, again, isn't technically a Kubernetes conversation. That's just, congratulations, you're running EC2 instances. Now you've got to configure them and manage them. Right? Sucks to be you. But we need to go in and configure these. And again, we can do this using CloudFormation. We can do this using Terraform. We can do all of the standard things that we've come to know and love over the last, you know, however long we've been playing with AWS. But when it comes to scalability, our nodes are only part of the conversation. So obviously, if we want to run a container, it needs to run on something, and that's our EC2 instances in this case. I will come back to Fargate later. So park the Fargate bit of your mind for a minute. But then we actually need to configure what it is that we're going to run on our EC2 instance. Right. And for that, congratulations, now we can officially see what's running or not running on our nodes in the management console thanks to the update from this month. So we can actually see it. But if we actually want to do anything about it, we actually want to tell Kubernetes that we want to run a workload, we actually need to go and get another tool. And for that, we come to the flexibility bit. And I'm going to take a little bit of a rat hole here, but that's okay. Kubernetes has a wonderful idea in that it's not going to be overly restrictive. It can let us run things however we want to run them. And with flexibility is a great thing. If I want to pump all of my logs out to a disk and then have it picked up, you know, and printed out on a printer, I can totally do that. If I want to export my logs into, you know, CloudWatch, I can technically do that. If I want to pump it out into, if I want to have Prometheus pull them out, I can technically do that too. It gives us all of these options. The downside to this, or the catch that comes with flexibility, is responsibility on your end, or our end in this case. If we, for example, want to leverage EFS and make EFS available to the wider, you know, Kubernetes environment, say we've got some, you know, EFS mount points with, oh, I don't know, all of our music files stored on it. We need to add some additional configuration to Kubernetes to get it to do that. It's not out of the box. If we want to provision ENIs in our VPC, like any service that has basic networking functionality, we can totally do that. But we need to add the AWS node daemon set in order to facilitate that. EBS volumes, same deal. We can add another daemon set. Logging, we can bring Prometheus in for that. All of these things are just more workloads, more pods, more daemon sets, more bits that we need to configure and run in our Kubernetes environment to get us to the point where we can host a website. This feels like a hell of a lot of work. Right? And I don't know about you, but I moved from looking after on-prem systems to looking after cloud systems because I wanted to automate my job and do less, not more. The maintainability part of Kubernetes is where we get to the wonderful kubectl or kubecontrol, or call it whatever you will, which is the answer to how we do all of this. If we want to deploy a daemon set, if we want to configure our workload, if we want to install any of these additional features or functionality, kubectl is how we do it, right? And that's great. It's, you know, it is, you know, facilitates the communication between us and the control plane, which is the cluster that we provisioned earlier. So this is all nice and wonderful. But of course, it's another tool. And we need to run this tool somewhere. And yes, it gives us some great functionality, like we can do declarative coding and tell Kubernetes exactly how we want our pods to be run, and then we can do a kubectl apply and pass the YAML file in, and it will go and provision it all, much like CloudFormation is also a declarative language and will simply deploy what you tell it in the way you tell it. But it's not like it's a new technology, but that's okay. So now we have kubectl, and we have the management console, or the CLI, and we have CloudFormation. And we're starting to get a little fragmented here in that we have all of these different components responsible for the different bits. We're going to use CloudFormation to deploy the infrastructure, then we're going to use kubectl to deploy and configure our containers. So our developers are going to be using one set of tools, our operations team are going to be using a different set of tools, which, you know what, if you're going to split your concerns between infrastructure and container configuration, that's great, but we've kind of spent the last few years trying to get dev and ops to work together, not separately. So having the dev team use a bunch of tools to deploy their workloads and having the operations team use a different set of tools to manage the infrastructure the devs are using kind of starts working in the wrong direction here. Shouldn't we all be using the same tools and the same technology, doing things the same way? No, maybe I'm wrong. And then we get to the observability thing. So we're, not particularly flexible, we're not particularly maintainable because we're using all of these different tools and we're pulling in all of these other daemon sets, and now we've got all of this stuff running in Kubernetes, and we've got a bunch of daemon sets, and if any of those daemon sets stop working, then the entire website's going to stop working because we can't access the storage, we can't get our music. But at the same point in time, if the AWS node daemon set doesn't work, then we're not going to be able to get an IP address, and then we're going to need the kube proxy so that we can actually get out onto the AWS network. So we're going to need something to sort of track all of this. And that's great, because again, if we follow the Kubernetes path, you talk to anybody about how do we monitor Kubernetes, the answer to that is Prometheus and Grafana. Or Prometheus and insert other visualization tool chain here. The problem with that is we need to be able to observe our Kubernetes environment when there's a problem with our Kubernetes environment, because we can't debug our Kubernetes environment without our monitoring and our observability, because otherwise we'll have no idea what's going on. So that by definition means that we can't run our Prometheus container in our container environment, which is a little problematic. So that's okay, because we used CloudFormation to deploy our Kubernetes cluster, so we can just deploy that again and deploy a second Kubernetes environment, and we can run Prometheus and Grafana and our observability and all of that in the second container, and we can even isolate that, and we can do it and look, we've gotten really good over the years of isolating workloads and one workload per account and separate VPCs, and we can do a transit gateway and load balancing and all of that sort of stuff. Totally not a problem. But do we really want to? Because that's going to get expensive. Running one set of production workloads in an environment is fine, right? We run one, we get the return on that because people are going to pay to stream the music, so that's all good. The observability is purely an us tool. It has no revenue. So we've literally just taken a whole bunch of revenue we've gotten from the first environment and basically spent twice as much, simply just to be able to see where the costs are going. So not a great experience from the from the affordability standpoint. But what actually becomes a little bit more of an issue is the human cost. Everything we've deployed at this point, all of our daemon sets, our website, our Prometheus environment, our Grafana environment. Yes, they're all containers, and containers compared to running EC2 instances or anything like that are a cakewalk to manage by comparison. Containers make operations a lot simpler, but the fact of the matter is they still require effort, right? And I'll let you in on a little bit of a secret. IT people are really expensive, right? Just, okay, that might surprise a few of you in the room. But we're pretty expensive people. And anything that we have to do or be accountable for or be on call for and respond to alerts at 3 o'clock in the morning to is going to cost us a lot of money. And that tends to be something that a lot of organizations sort of overlook when they're, drawing out their architectures and sort of coming up with the plan of what all of this is going to look like. So, yeah, a Kubernetes cluster on AWS runs you about $75 a month USD. Not going to break the bank, really. All right? But when we then consider the fact that we're now managing twice as much infrastructure, plus we're managing the underlying nodes, the underlying pods, and all of those sorts of things, this price is starting to add up in the number of hours a week that we're going to have to spend running it and maintaining it. Because again, at the end of the day, the customers don't care whether or not Prometheus is running. They don't care how fast it runs. They don't care whether or not it's up to date. They don't care whether or not it's patched, unless it's compromised, but we won't go down there. All they care about is that cluster on the left-hand side that enables them to stream their music. So even if we do a fantastic job on the right-hand side, any issues on the left-hand side are going to undo all of that effort that we've invested. So that's going to leave us with a little bit of a problem. And that's fine, because what we can hopefully do is we can do what a lot of organizations do and backfill our team with support from the vendor. The problem with that is Kubernetes is open source, which is great in a lot of regards. The catch with that, of course, being, and I'm going to use a term here that I really don't like, but somehow got thrust into me back in the Telstra days, it doesn't give us that single throat to choke. When things go bad, yes, we can go to a partner, right? Kubernetes has loads of partners, and there's a number of them. There's a number of people who work for them in this room right now, all right? So it's not like there aren't options, but at the end of the day, the vendor is always the best person to go to when things go wrong, because they will have the support, they will have the personnel, and ultimately they are the ones accountable for making sure that you've got a good experience because it's their product. Now, I don't want to spend too much time bagging on partners and all of that. I do, after all, work for a partner of AWS, so the partner ecosystem has its benefits. But it is another thing that we have to consider, that when things go horribly wrong, we may need to be cutting some pretty big checks to some partners at the last minute in order to help us dig ourselves out of the hole. Not the end of the world. We can hire smart people. But, Kubernetes does update itself once every couple of months. So, you've got to be staying on the ball in order to make sure that, you've got yourselves supported. So, our scalability is doable, but it's going to require a lot of tools. The maintainability isn't great because we've got a lot of tools. The flexibility is there, but that's going to require a lot of work on our part, which is in turn going to need a lot of observation and support and operational assistance from us, which is going to cause us an affordability problem because we're going to need more staff and more personnel to help manage all of these workloads. But that's okay because we're going to go to a partner and pay them a huge amount of money to dig us out of the hole when all of this stuff goes up, and ends up being a massive problem, and the website goes down at 3 o'clock in the morning and people can't stream their music anymore. But that's okay because we've got Kubernetes and we've got Prometheus and we've got Grafana, and my resume looks awesome now. So that's okay. As long as I get a new job before the platform dies, everything is good. But is there an alternative? And for anybody who's done any work with me in the past, they would have known the answer to this question already. But the answer is Elastic Container Service, if you're going to go down the container route. Now, quick disclaimer here. I have told you everything up to date, knowing full well that I am on the record back in 2017, I believe it was, at an AWS Summit event, saying that containers are nothing more than a passing fad. I am willing to admit that may not have been entirely accurate, and that containers may be here to stay. Serverless, I still think, is the long-term answer, but we won't go down that road. But for the moment, Elastic Container Service is our friend. And if we sort of run through what an Elastic Container Service might look like, we actually see that it's relatively straightforward. And there are not actually that many moving parts. And in fact, if we get back to the same 6 points, we can have scalability here. Now, you will notice the Fargate box on this diagram, and I said I was going to get back to Fargate. ECS is an AWS service, which means it integrates nicely with other AWS services. Funny that. Doesn't always happen. There are times when AWS services don't play nice with other AWS services, and for anybody who's spent any amount of time with AWS, you've probably experienced that. But ECS leverage Fargate, and when you leverage Fargate, you get almost a like-for-like experience, and or from a functionality standpoint, as you do when you run it on EC2 instances. That is not the case with Kubernetes. With Kubernetes, if you run Fargate, you lose things like daemon sets, for example. All of that functionality we spoke about before, you need to sidecar into your container. It's not impossible, but it's additional configuration that you're going to need to do and think about and manage and all of those sorts of things. Whereas with Elastic Container Service, we've got Fargate, it gives us the same level of functionality, and all of a sudden we don't need to worry about managing all of those underlying hosts. Which in turn, again, slightly outside the topic of the conversation, but it also means we don't need all of that image builder and pipelines and all of that sort of stuff to manage the nodes and build them and test them and deploy them and update them and all of those sorts of things, because again, our customers don't care how automated and how cool that technology is. They just want the website to run. And if it's not going to give the customers any better experience and it's not going to make my life easier, then why do I want to do it? So I will go Fargate almost every time. The maintainability part, we can deploy everything on that diagram using CloudFormation templates. It is flexible because, again, it is all deployed with CloudFormation templates. We can leverage any AWS service. We can plug it in to our environment. We can expand our service to use all of those components. Observability is managed by CloudWatch. And CloudWatch doesn't need us to do anything. We don't need to manage the infrastructure. Why would we want to? It doesn't provide us with any benefit. It's simply something that we just want to consume, leverage, and not have to worry about. Affordability, well, we only have one cluster because we don't need to run a second one to run our observability layer. We're able to run Fargate, which means we're not having to pay for additional EC2 capacity that we're not using. And we have a lot fewer moving parts and a lot fewer tools. In fact, we're only using CloudFormation to manage. So the affordability is significantly better on an ECS environment than it is a Kubernetes environment. And then finally, supportable. Well, this is an AWS through and through solution, so you could totally come to a partner like ourselves, and we would be able to help you with this. Or if you give AWS enough money, they will do it for you. You can go to them and make it their problem. So Elastic Container Service kind of gives us a whole heap of benefit. But, and this is the number one but that I hear from a lot of customers, what about vendor lock-in? If I use Elastic Container Service, it's then going to be really hard for me to pick up my workload and move it to another cloud. To which I have two questions. The first question is, why would you want to do that? There are a couple of use cases where that might be necessary, but to engineer an entire environment specifically so you don't get vendor lock-in is the same thing as kitting out an entire data center with servers from 20 different manufacturers because you don't want to be beholden to Dell or HP. And I can tell you, as someone who used to manage data centers, that's a terrible idea. You want a unified control plane. You want to make it as simple as possible. And the nice thing about vendor lock-in is when you're spending all of your money with one vendor, they tend to do you a really good deal. The other problem is that whole flexibility, capability piece. That is a list of every AWS service available as of this morning, copy and paste it out of the management console. Do not ask how long that took. I hope AWS don't release new services quickly, because otherwise I'm going to have to constantly update this. Yeah, I've dug myself a big hole and I'm aware of it. If you're going to lock yourself into just using Kubernetes, that is a base level of services that you're still going to need to use. All right, you're still going to need auto-scaling. You're probably going to need budgets. You could probably do without it, but you can probably only do without a budget for so long. You're going to need the console, Cost Explorer, Kubernetes. You're going to need IAM, that's a non-negotiable. EFS, because that's where our music's stored. Organizations, because I'm just going to assume that you're doing this in a multi-account layout, because if you're not, we need to have a conversation. Resource groups and tagging, same deal. If you're not tagging things, well, yeah. Says the guy who doesn't have any tags in his personal account, but again, builder's house scenario there. Support and VPC. All of that stuff is going to need to be rebuilt if you were to move to another vendor or another cloud or another environment. So even if you kept everything in Kubernetes on any cloud, there is always going to be a huge amount of re-engineering that you're going to need to do. Now, all of that is to say that we basically boil this down to 6 concerns. And they're not roadblocks or anything like that. They're just things that we need to consider. Kubernetes on AWS requires multiple steps and mechanisms to deploy a cluster. All right? Right from the outset, we are setting ourselves up for a lot more complexity than we would by going with other services. Its management and configuration is managed outside the standard AWS toolchain. We're using kubectl to do all of our RBAC and our deployments and our configurations and our updates for our containers, whereas we're using other tools for everything else. Integration with common services requires additional configuration components. So these are things like the daemon sets in order to get EBS, EFS, container insights or anything like that, all requires additional deployments on our end. And none of it is manageable through the control panel. The learning curve. Just to put this slide, it has taken me 18 months to get to the point that I am at with Kubernetes right now. And I can tell you that I am still just a beginner. And I've been playing with Kubernetes, I've been working with Kubernetes for 18 months in production environments, and there is still a bottomless pit of information that I need to learn. Do not the weeds, right? It is a bottomless pit of complexity. It does little to manage and control cost, other than make it go up. And then finally, support is partner-led, so has no single throat to choke. None of that is to say don't use Kubernetes. There are uses where Kubernetes might make sense. Extra slide. Kubernetes provides a lot of flexibility and customizability and offers a consistent developer experience across platforms and hosting infrastructure. For example, if you happen to be, I don't know, let's pick a random organization like a bank. And you, by law, need to run your environment across multiple data centers, multiple vendors in order, to comply with government legislation. Kubernetes might be a way for you to provide a consistent experience for your developers across multiple environments. Kubernetes might be a really good choice for you. If you're a global IT organization consisting of 50 or 80,000 developers geographically distributed around the globe, and you want to provide them all with a globally distributed, unified development environment, like, say, Google, Kubernetes might be a good choice for you. For the other 99.99% of organizations on planet Earth, yeah, don't. So, I will take questions offline because we've just hit 8 o'clock, unless there's any from online. No, there's no from online. So I'll take questions offline. But based off all of that, I will leave you with the following question. If you had to front the investors at the end of the week for phony music and propose a technology roadmap, which one would you pick? No, you weren't listening.
No, I wasn't listening. Thank you very much, Matt. Thank you, sir. So, as Matt rightly pointed out, we are at 8 o'clock, so we'll wrap it up there. Let's see if I can stand over and get out of the way of my slides. Hooray! So, big thank you this evening to our speakers, to Phoebe and to Matt. Applause. Thank you. As well to our sponsors, CMD, Versant, Seaver, and NAB. Thank you very much. We'll be back here again on the last Wednesday of June, which I believe is the 29th. Thank you very much for coming. Yeah, that's it. See you next time.